Welcome to this topic, electrostatics. We continue to emphasize on the numerical calculations in about electric field intensity, which is denoted with E. We have example 3, which reads, calculate the electric field at a corner of a square, 42.5 centimeter on a side if one corner is occupied by a negative 38.6 microcoulomb charge and the other three are occupied by a negative 27.0 microcoulomb charges. Of course, these are answers. We shall see whether we come to those answers. So let's see the interpretation of the question. The diagram here shows the illustration from the question, and I'm assuming that the edges, the vertices of a square, are denoted with letters A, B, C, and D. And according to the question, it is only one side which is having a negative 38.6 microcoulomb, and that's C. But the rest of the corners or vertices are carrying a negative 27.0 microcoulomb charge. So where the diagonals, for example, diagonal SC and diagonal DB, where they meet is O, so that point is the point where we want to find the electric field intensity. And the sides are equal because it's a square, 42.5 centimeter each side. So since we want to find the electric field at O, it is going to be due to the 4 charges around it, because point O is going to be within the electric fields created by all the charges. But for simplicity, we are going to deal with each charge independently. We must remember that E is equal to KQ over R squared, where K is known, Q is the charge, magnitude of charge, and R is the distance from O to any charge that we are going to consider. And then let's start with E. Let's use red. So we are going to find E at O due to A. E at O due to A is going to be 9 times 10 to the power 9 times the charge at A, which is 27 microcoulomb, that's power negative 6, divided by the distance x. Let's say the distance is x but squared. So the distance is x between O and A. It's not known. Let's try to find it. Since this is a square, the diagonals must meet at 90 degrees. So that means this is 45 degrees and that's 45 degrees. That is also going to be x. Distance from OB is the same as OA. So since we have a right angled triangle, we can use, like, to get x, we can use whatever we wish. Let's say sine of 45 is equal to opposite, which is x, over hypotenuse, which is going to be 42.5, and that means that x is going to be 42.5 sine of 45. And if you want, remember sine 45 is 1 over root 2, so you can write this one as 42.5 divided by root 2, which is going to be the same as 30.05 centimeters. Okay, so EOA, if you feed in x at 30.05 centimeter changed into meters, is going to give us 2.61 times 10 to the power 6 Newton per coulomb. So that is got. Let's go to E at O due to B. E at O due to B. Before maybe we go there, let's see the direction of EOA. So EOA, we know that at A we have a negative charge, so electric field should go into a negative charge. So that is EOA. Then EOB, it is going to be EOB, so B is a negative charge. EOB is going to be also towards B. This is EOB towards B. And you realize that the charge at B is the same as the charge at A, so the value that we shall get is going to be the same. It is going to be the same as EOB. Okay, let's go to D. D is a negative charge, and since it's a negative charge, it's the same charge as the one at A, the one at B, negative 27 microcoulomb. If it's negative, then the direction of E at O due to D is going to be towards that charge. So that's going to be EOD, and the negative 27, the distance is going to be the same. So that's going to be the same as EO due to D. That's done. Now we have one more remaining. We get EO due to C. So we realize that the charge placed at C is different from the rest of the charges, so this is going to be different. We can calculate it. 9 times 10.9 times the charge placed at C, which is 38.6, exponent negative 6, well, divided by the distance, which is the same, it is x. So distance OC is x, and we have it as 30.05 centimeters, which is 0.305, but squared, and therefore this gives us 3.73 times 10 to power 6 Newton per coulomb. That's it. So we have all the two. Let's see the direction. At C, it is a negative charge. It's a negative charge, therefore the E should be towards the negative charge, that is E at O due to C. Now we have all of them. We have all the electric field intensities. Let's check the next diagram. So this diagram, as we saw that this is E or C, then this one was E or A. Then we had this one also was going up, was EOD, and then we have this one was going towards a negative charge, it was EO due to B. Now we are going to find the net electric field intensity at O. So when you look at E, we have already seen that we have vectors in line. So EOD is in line with EOB. EOD is in line with EOB, but you realize that they are in line, opposite direction, but they are equal. EOD is equal to EOB. So if they are equal, it means that in the line DB, there is no effect of E. The net electric field in the line AD is equal to 0 because they are equal but opposite direction. Let's go to E at O due to C and is in line with E at O due to A. These are not equal. They are different. We have them. So they are the only, so the electric field intensity at O is only due to the fields EOC and EOA, because they are not equal and they are in line. Therefore, E at O is going to be equal to, let's say, EOC minus EOA. It's minus because they are in opposite direction, but this direction that we have chosen is towards, it is towards C, where C is negative 38.6 microcoulomb. So if we feed in the values, we shall get, let's see, EOC was 3.73 times 10 to power 6 minus EOA 2.61 times 10 to power 6. So finally E at O becomes a positive 1.12 times 10 to power 6 Newton per coulomb towards C, or you can say towards the negative 38.6 microcoulomb. Again, in summary, because we have seen that the electric field at O, the net electric field at O in the line DB in this direction here, in this line, in that plane, is equal but opposite, so it cancels out. We remain with the net electric field in the direction, in this direction, and therefore when you subtract them coming in the opposite direction, you remain with 1.12 times 10 power 6 as the answer.